Hi, everybody. Good morning. It's November 2nd today. Welcome, everyone. So, we're going to jump into our quick attendance check. And our attendance check is going to be in the chat. It's what do you look for in a friend? So, basically, what are qualities you look for when you're making friends? And you could go deep with this, or you could be very general, like, hey, they're nice, they're this or that. All right, we got loyal. Yeah, that's super important. Supportive. I put compassionate. Gotta have a friendly personality. Trustworthy. Uh-huh. What good are friends if you can't trust, right? Understanding. Fun. Loyal, trust, and sees the good in me. Funny. Someone you can bond with. Yeah, like definitely you gotta make sure you vibe with them. They gotta have a sense of humor, not be like all serious all the time. Understanding and trustworthy. They can't get mad after I roast them. People get booty hurt after a joke. Okay, those are some qualities. Kind, yeah, kind friends. What else we got? Let me just make sure I have everybody. So thank you all for like so far for sharing. Like what are the qualities you look for in a friend? Super important to know that. Um, but here's who I don't have so far, and that was based on that attendance check question on what do you look for in a friend? Okay, great. We have some more. Someone who treats others with respect. I look at a lot of things. Yeah. Being very observant. Oh my goodness. Yeah. It just reminds me of me in high school. I only had I didn't actually really have much friends. I only had I had a bunch of cousins at school and I would just hang out with them. But yeah. All right. So this is who I have who's not here. I don't have Ariana. I don't have Tyree, Dennis, Miles, Kayla, Marvin, August, Marco, Joshua, and Bianca. So that's who I'm missing. If you're friends with them, please tell them to come on into class. We are basically in our last week of this module, basically. So that means we're jumping into, mini final preparations and all of that. So it's gonna be a filled in week. Uh, because it's so fast paced. Okay, we're getting some more people in. Give me a sec, everybody. So we have Joshua and we got Miles in now. All right, cool. So again, I'm missing Ariana, Tyree, Dennis, um, and we just got Marvin and a lot more. Super happy. Welcome, everybody. All right, cool. Let's go ahead and jump into our agenda, everybody. Let's go. So, because we're going to be jumping into our mini final today is basically our last kind of lesson, like our last like new thing to learn before y'all are ready for that mini final and your attempt on it. So the mini final is now posted. The first draft, I definitely underline draft because I feel like a lot of people are getting stressed if they look at it and they're like confused. What I'm asking for is draft. That means it's okay if you're uncertain. It's okay if the answer is wrong. I just want you to attempt it. That's your first draft, and that's due on Tuesday, and it's an attempt. Um, Also, yes, I had do the big ideas packet. You know, when y'all make those comments on it, basically the big ideas packet. That's the only thing. That's the stuff you need to succeed in that mini final, basically. So you want to make sure that you're looking at the big ideas packet thoroughly, so you understand what's on there. I also like organized it better. Like I improved it so it's not just some giant document where you're scrolling in. Now it has a table of contents. So it's nice and improved. I'm hoping to make more of those like that so it's easier for y'all to follow along. But yeah, so that's just an update on that. Today we're gonna talk about finally like we've been talking about Riemann sums, right? But not really how to do it by hand. Like for you all to draw the actual rectangles by hand, left or right, right? So we're gonna have video instructions on that. Some of you who looked at the Big Ideas packet maybe got a peek of this video because I did actually attach it in the Big Ideas packet as well. But if you didn't, it's okay because we're gonna look at it today. Then we're going to be having a group participation for credit. It's going to be a group Desmos where you're going to try to apply what we did, what I do in the video, to your group Desmos today. At the end of everything, then we're going to come together and have a checkout question. And let me check the chat, y'all. I see some stuff in the chat. So yeah, like a study guide, Jeanette. So the Big Ideas is like a study guide for what you need for that. Basically, it's like all the stuff we learned, but like condensed. So it's like straightforward, and you're gonna try to apply it into the mini final. And yes, you will still get credit for turning in drafts, Jorge, for sure. That's why I encourage it. Like turn in what you can for sure. Yeah. Let me go ahead and admit. There's somebody called Kimani. I'm not sure. I'm gonna admit them, but I'm worried. I don't know who that is. Um, I'm just worried that we're gonna get like oh, okay. Okay, sorry, it is okay. Okay, cool. No, we're all good, everybody. Okay, so great. So that's what we're doing today. Let's go ahead and jump into it. So basically, in order to be prepared, make sure you have some paper. I'm going to show a video. It's going to be about 8 minutes. I'm going to go over it right now in a second. But before that, of course, I already talked about this new and improved Big Ideas packet. Really nice. You could like literally click on the link and it's going to take you to that big idea. We have about 9 big ideas. And I also added an exponential function review because, hint, hint, that might be something you might need for the mini final. And I even included essential like vocabulary as well at the bottom. So new and improved. That was due yesterday, but guess what? I haven't yet, looked at him or graded it yet. So get them in if you still haven't gotten the Big Ideas packet. It's so this assignment is in my opinion, the lowest ever because all you got to do is make 8 comments on it. 8 questions or 8 understanding. It's pretty straightforward. So I recommend definitely doing this assignment if you hadn't yet. Okay, so please have paper pencil ready. This is going to be the video notes, and the title of this is actually constructing the Riemann rectangle. So you are like drawing it now instead of me giving you something that's drawn like, oh, here's the rectangles, find the area, it's now you being able to draw them yourselves. So constructing Riemann rectangles is the title. Our learning target is I can construct right or left Riemann rectangles. Let me give you all a few seconds to get this down in your notes. All right, cool. I hope you all got the title and the learning target down. Um, so we could jump into it. So this is what the video notes looks like. So I recorded the example, and the reason for this is because I wanted to make sure I'm nice and concise and don't take up like 20 minutes talking about it. So it's about 8 minutes long. Take notes and follow along the process. And don't worry, like let's say I play the video and you're like, wait, I missed something. Don't worry because the video is actually already linked up in the Big Ideas number 9 in your Big Ideas packet. So you can go back to the video whenever you'd like to review the instructions. So like even if I click on my slide here, take a look, it's gonna take me to that specific big idea. See, it's going to move me down. There we go. And it says video recording is linked right here. So basically, the big ideas packet is going to have all your resources that you need. Um, Let me just X out of there, but that's just showing you that it's all in there. So you could go back to the video whenever you like. And here's the video. So while y'all are watching the video, go ahead and take notes. Like I said, if you want to watch the video like at your own pace, you're free to do that also later on. But this right here, we're gonna watch, and then we're gonna be broken up into groups so that we can apply this in a group Desmos. Let me know if anyone has any questions before I start this video. So yes, you should be taking notes during the process. People, how many people in the group? Usually about 4 is how I make the groups. And usually for this period, it has been at random. Unless you all have any specific concerns of who you can't work with, just make sure you private message me. All right, let's begin, y'all. Let's first take our notes, though, before our group. So again, this is about 8 minutes. Let me start it up. I'm gonna turn off my camera. Everybody, just turn this up. It's gonna be loud, so if it's too loud, just turn down your own volume. All right, let's begin. Okay, so this is the support video on how to actually construct, like create your rectangles under your curve. Here I made some steps for you all that you copied down, and we're going to try to apply it to this here function. We have y equals 2x, that's graphed, and make this thinner, the line. Okay, we have this function right here that's graphed for us already. It's an increasing exponential, and we want to create 4 left endpoint rectangles. So we're kind of being told to use left endpoint rectangles, and the interval is from 0 to 2. And then ultimately, this problem is asking to find the area of the rectangles, right? But in this particular lesson right here, all I'm showing you is how to construct them, since we've had lessons on how to find the area of the rectangles once we're done. All right, so here we go. Let's jump into step 1. So step 1 says decide on the rectangle width. Now, you'll have more freedom to decide on your rectangle width, but in this case scenario, we're kind of stuck. We can't really decide on the width because we're being asked to do 4. So let me put step 1 down here. Let me put step 1's work down here. So I'm going to put step 1. I know, forgive my messiness. It's hard. So step 1's down here. Step 1 actually has, like, I feel like the most work maybe. So it says decide on the rectangle width. So how thick do we want our rectangles on the base, on the x-axis? And what we do here is step 1 is, in order to determine the width of each one, what we do is on the top, we're going to be dividing. So on the top, we have length of the interval. I wonder how I could shorthand that. So length of the interval. I'm just going to put int. That means interval. And what you do is you divide it by the amount of rectangles you want. I'm just going to put number of rectangles. And with this formula, you'll be able to find any like rectangle width that you desire. Okay, so let's apply step 1 to this particular problem. So in this particular problem, our interval is from 0 to 2. So from 0 to 2 right here. The length of this, of course, is going to be 2 minus 0, or just 2. The length is 2. Divided by the number of rectangles that we desire. The problem is we can't choose here. We're given it. So we want 4 rectangles. So we're going to divide it by 4. This process right here is going to tell us the width of each rectangle. 2 divided by 4 is the same thing as 1/2. And if you don't know that, you can use a calculator, but it's also 0.5. Coincidentally, I know we keep seeing 0.5. There are different widths that you'll get to explore today. So here's our width, 0.5. The width of the rectangles, in this case scenario, 0.5. And here's our step 1. So I'm going to put a check. We did step 1. Now, step 2 is partition the x-axis with the width that you decided on. So here's our x-axis, and we're going to go ahead and partition it by 0.5 each time. So from 0 to 1, I know that in between there is 0.5. So here's 0.5, 0.5. So that's 0.5, and then 0.5 plus 0.5 is 1 right here. Then 1 plus 0.5 is 1.5. And then, of course, 1.5 plus 0.5 is 2. So there, we've partitioned our x-axis, and I'm going to additionally, in a different color, use the subscript notation so that I keep my work organized. So the first endpoint is x sub 0. Next one's x sub 1. Next is going to be x sub 2 down here. X sub 3. And then x sub 4. Okay. Now that I've done that, I've completed step 2, and I partitioned, and I even went a step further. I've also, organized my work, and I labeled it. Step 3 is just decide whether you're going to use the left or right. Again, this problem is limiting because it's telling us to use the left. So we're going to be using left endpoint. So step 3 is done for us. So again, for more open-ended problems, you'll be able to decide to use right or left. Okay, now we could jump on to step 4. Use the endpoint you decided on. So it was left because they told us left. And we're going to draw a straight line up to your function's curve. And then step 5 is draw the rectangles. So I'm going to kind of do step 4, step 5, step 4, step 5. It's just easier for me, but you could do step 4 and step 5, whatever works for you. And okay, in order to use the left endpoint here, because we're using the endpoint we decided on, you have to look at your segment. The first segment is right here, from 0 to 0.5. In other words, from x sub 0 to x sub 1. Now, between x sub 0 and x sub 1, the endpoint that's on the left is x sub 0. Because we're doing left endpoint rectangles, this is going to be where we draw our line up to hit the curve at x sub 0. This should be a line, and we're going to just put a point there. And then you're going to draw your rectangle. This is step 5. You're going to draw your rectangle, and you're going to stop until you hit the next endpoint. And then you're going to draw a line down as straight as you possibly can. There's our first left endpoint rectangle. Notice how the upper left-hand corner is touching the graph. Now the next one, so for the next segment, we have 0.5 and 1, or x sub 1 and x sub 2. The number to the left, or the endpoint to the left, is x sub 1. So we're going to start at 0.5. We're going to draw our line up until we hit our curve as straight as we can, which is right here. And again, we're going to draw a rectangle until we hit our next endpoint, which is at 1. And we'll try our best to do a straight line. I think this does have a straight line tool, but that's okay. Okay, we're almost done. We have 2, we need 4. So let's keep going. So again, this is 1 and 1.5. Again, this corresponds to x sub 2 and x sub 3. The most left endpoint here is going to be x sub 2. So we're going to draw our line up from x sub 2 up until we hit and touch our curve. Then we're going to draw our rectangle until we hit the next endpoint, which is 1.5 right here. Notice again, they should have equal widths if we did this correctly. All right, last one. So between 1.5 and 1, the most left endpoint on this interval, this specific last interval, is going to be x sub 3. So we're going to start at x sub 3, and we're going to draw our line up until it hits our curve. Then we're going to draw a rectangle until we hit the last endpoint, which is at x sub 4, and also at 2. There we go. So we've constructed the left endpoint Riemann sum, or the left endpoint rectangles, to kind of later on find the Riemann sum. So we've done all steps. Of course, this problem is asking you to find the area. Y'all can do that later, but again, this right now is just practice and a tutorial. on how to do how to create the rectangles under your graph. All right, y'all, apply this in your groups now. Cool. So let me so yeah, so that was a video. I hope y'all took some notes. But again, you will have time to also like process it with your group and try to figure out how to make sense of those instructions that you just saw. Again, if you're like needed the video to slow down or something, like I said, don't worry. You all have access to this video in your big ideas packet. It's linked up in big ideas number 9. Just so you could go back. You could also go into my slides and click on the video as well as an easier way to just access it. All right, so please, I hope y'all took your notes. Now it's going to be time for our group activity. Now this is going to be graded for participation as long as you're actively participating. The expectations are, hold on, I see 2 things in the chat. And then do we have a link for that video? Yes, the link is in your big ideas packet, or the slides are also on Google Classroom. You could just go in my slides and click on that link as well. But I could, you know what? Let me just also just put it in the chat too. Let me do that. That way, if y'all want to just look at it as well right now, you could totally do that. Put that right there. But yeah, so here's my expectations for our group thing today. So complete the activity fully with your group. I mean, of course, I'm going to be jumping into groups. I'm going to be checking in where everyone's at. And like, you know, of course, it's going to be like fair, like, oh, like if we don't get to finish, we'll talk about that. Make sure that everyone puts their name and role for their credit. At the beginning, there's going to be like the name and the role. Only one person will need to log in for everyone, like last time. Every group should be screen sharing. So when I jump in, you should be screen sharing. Again, the most common technical issue is that even though I keep putting that everyone can screen share, sometimes I have to go group to group to make sure I give you the access, which is weird. But I'll make sure that happens. And all the instructions to log into Desmos are on Google Classroom. Let me know if anyone has any questions on the instructions before I start making our groups. Just on the instructions portions. Any questions? All right. All right, so give me a second. Let me go ahead and create these groups. We're gonna, again, it's gonna be about 4 people per group. All right, I'm gonna open up the rooms. Y'all just gotta accept it. I'll see y'all soon. Accept the invite. Miles and Alasia, do y'all see an invite to a group?
Yes, I see it. I'm sorry. I was looking at something to say to you guys.
It's okay. You said Marvin, right? Hey group. Y'all only have 2 people. Tyree and Jose. Mm. Y'all, so Tyree and Jose, I'm gonna go ahead and move you into a bigger group because some of us didn't join, okay? So just click accept on the new invite. Give me a second. And I'm going to move you, Tyree, to group 6.
In alphabet. So who's that? I think that's me.
Hi, group. I made sure y'all can share your screen. Let me know if anyone has any. Okay, awesome. It'll just be popping out in a bit.
Damn near, bro.
Oh, we gotta wait for. Oh, you can go now. Next slide.
All right.
Want to watch the video again, or we feel like okay, going on?
I think I'm good. What about Jorge?
Yeah. What did he put on the chat?
He's good.
Okay, great. Okay, use.
Wait, is this the video we just watched?
Yeah.
Okay, for sure. Do y'all need to watch it again, or y'all good?
Well, I'm good.
I'm good. Anybody else? For sure. Use the drawing tools to create them. Okay. I'm gonna circle important information. I feel like this is the one we did in the video, but it's okay. All right. Okay, so we're starting from 0. So I'm going to put X. Okay, this is gonna be fucking difficult.
So is that like that?
I think. Wait.
Like, cause half of each one. I don't know. I'm just.
Yeah, I have that for my step 2, but it says for step 3, it says decide whether you use right or left endpoints.
Yeah, we're trying to do step 2 right now. Like we gotta actually part the x-axis with the width that we decided on.
Which is 2, right?
I thought we said 0.5.
If it's 0.5, then I think you're right.
Okay. Okay, so step 3, decide whether you'll use the left or right endpoint. Oh, okay, we want to create 4 left endpoint rectangles, so it already tells us. So I'm gonna just
Because it says to.
Left endpoint rectangles, yeah.
Okay.
Da-dee-da. Sorry, I like to make noise when I'm doing something.
It's okay. It's good elevator music.
Thank you. Thank you for listening to my podcast. Just kidding. Sorry, I'm going too far. Okay, so we have 4 rectangles. Does anybody want to add anything or?
I think that one's good. I think that one's all set.
Okie dokie.
Yeah.
Mm-hmm.
Huh? I probably. Question y equals x. Input. So are we supposed to draw the rectangles again?
Yeah. So it's the same one.
I think we have to do it for the right endpoints.
Oh yeah. That's
Yeah.
Oh.
So now the right points are touching the other side of the graph.
So the left side.
So they're basically the same triangles, but I guess a bit taller so that they can touch the right endpoint.
Practically all
So
red.
would you say like from um 2 to 1.5?
And something like this. So this is aim point. Okay, how do we feel about this?
I think it's good. I think.
How about you, Jorge? We're good with this. Is it like the last one? Yeah, so like this was left and this was right. Like the left is under and this one is like over right, the line. Okay, answer the following group. Discuss how your group will approximate the area under the curve for the function y equals 2x. Discuss how you will connect your process to our big ideas.
I think
I mean,
we
'cause-
should redo our points or something.
okay. So like just start over.
The first, I don't know.
Because it says 4 left endpoint triangles between x equals 0 and oh, okay. I see what you all mean. Okay. Because it has to be between x equals 0 and x equals 2. So like we're not supposed to go like all the way to 4. So we just gotta do 4 over here.
Shouldn't we start on 0?
Yeah.
Yeah, I think we should start on 0 because last time it didn't work.
Okay, so like that. Because the width is 0.5 and then we need 4 rectangles.
No, Jorge in the chat. I mean, sorry, Jose in the chat says yes.
Yeah.
Oh, okay. I'm like not checking the chat, my bad.
No problem. When you're sharing screen, it's hard to see the chat.
We can use sigma notation to try and is it to like reduce the expression? I don't know.
So, wait 1 second.
Yeah, you gotta give me a second. I'm on the gram.
Oh my god.
I'm just messing around. No, what were you saying though?
Because it's asking how to approximate the area under the curve. So then wouldn't we get the rectangles, the area of every rectangle, and then add it together to get the area?
I think the line passes through some of the rectangles though.
Well, I
No, I
mean,
mean, she's right though. It's an approximate. Yeah. You just you find the area for every single rectangle and add them together. That's
So
just
do
it.
I go back?
No.
Well,
I'm pretty sure we're just writing that explanation down. like how you would.
Yeah, we're just writing the explanation.
So how would I rank this?
Henry is in the chat that said, I'm going to just type what I would write in it.
All right,
Okay,
sweet.
so then we can take
That's
Henry's
pog.
and then just
That
copy it.
is pretty poggers.
That way you can just kind of like
What?
review it and stuff. Like you can just like give your opinion. If we need to fix it, we fix it.
Okay, Henry, right.
Miles has such a awesome vocabulary with his words. I don't even know.
I think I should stop applying cream to my tattoo.
Oh my god.
Like, not even.
Am I the only one that knows how to do this?
Yeah,
Okay. Oh, all right. So the steps you have to do, or you have to just.
How to solve the problem? I think I know how to do this.
Well, what I do is I just look at the. How do I explain this to you? Oh,
I don't know.
it's hard to explain. Like I know how to do it, but it's like really difficult for me to explain it.
Is this finding the area?
Yeah, just finding the area under the curve.
That's not that bad. Oh wait,
You
these
just-
steps are kind of weird though to explain. I ain't gonna lie.
Well, first thing you have to do is find the height of the rectangle, and then you're supposed to, multiply that by 0.5. You understand?
Yeah, that sounds good. Who's typing that out?
I was about.
Ethan.
Oh, okay, perfect. I think you're doing good, Marjorie, in describing what to do.
Okay. Yeah, because I was like, I don't know if I'm explaining it right.
Good.
Okay, would y'all say something like that? Because we have to use the right endpoint.
Yeah, because it's touching the line.
But is it supposed to go over?
Yeah, it is.
Yeah, because the right endpoint is always an overestimate.
Hi, everybody. I'm just bringing everyone back. Usually takes like a minute before everyone's fully back. Welcome. We're going to take a look at some of this, and I'm going to try my best to give some feedback in case I see any errors. Welcome, welcome, everybody. Hi, I think we have everyone back since I have 22 of you back. Welcome back, everybody. So we're gonna come back and we're going to, sorry, were y'all, whoever's on it can finish up your group thoughts if you still had more group thoughts, but I'm just bringing us back to kind of just, sometimes like I just bring us back to either identify common misconceptions or just kind of give shout outs to good stuff I saw. So I'm gonna first, just to make sure it's comfortable for everyone, I'm going to anonymize. Again, everyone who put your name on here, like for example, I don't know, there's someone called Juju.
That
Just
was
make
Juliana, but I
okay.
didn't
You
want to type out
seriously
her
put
full name.
Juju?
I'm like, I don't know. Okay, just make sure. Okay. So that I know who everyone is, so I could give you your credit. But I'm gonna go ahead and anonymize this so I could give some feedback to groups. So these are our anonymized names. Okay. So again, the video was there. I think most groups didn't really need it. They moved on from it. And here are the graphs that I saw. Most of these look very similar. One thing, my first notice is when I'm looking at this graph, I do notice that because it asks for left endpoint rectangles, that all of these graphs had that the rectangle's upper left-hand corner was touching your curve, which is, which is consistent with what we were learning about left endpoint rectangles. This group went further. They even labeled the bottom with subscript notation. So that's, awesome job for doing that. I loved that some groups also circled important information. Like I was like really happy when I saw that happening. Again, all of these had that the upper left-hand corner are touching your graph. So I noticed that with all of these, this one here as well, the upper left-hand corner is touching the graph. Okay, so now as far as feedbacks, then my group used orange. Okay, Miles. So as far as feedback, so my only feedback would be right here for Kelly's group right here. So my feedback for you is notice how this is the only difference graph here. So I definitely want to just talk about it. So this one right here would be, the graph is almost there. I'm gonna say that. So it's almost there, but you want to be careful. And this is feedback for this group because you want to make sure that you start at x equals 0. So basically, there should be a rectangle that's kind of encompassing. Basically, notice how there's no rectangle here. You want to make sure that you start at x equals 0 and you stop at x equals 2. So that's my feedback. So notice how actually this group, you went past x equals 2. There's an extra rectangle past it. So you kind of want to shift your graph over like 0.5 units that way. But otherwise, like you all accurately separated the graph correctly. You all did the rectangles correctly. I mean, this is a good piece of work. I'm super proud of it. Those are just my slight feedbacks for this group. Let me go ahead and clear my drawings. Boom. Awesome, awesome. All right, so let's take a look at this next one. Again, all of these, and y'all can take a look, all of these have that the upper right-hand corner is touching the graph. All of these have that. And again, hey, this looks like the way I do mine. Like crooked rectangles, that's okay. It's still correct. Awesome. Awesome sauce. And likewise as well, I see that the upper right-hand corner, again, it's very similar feedback for Kelly's group. Is just making sure that the question says you start at x equals 0 and then you stop at x equals 2. So you just want to make sure that those 4 rectangles are between 0 and 2 on the x-axis. That's my only feedback. Otherwise, I'm really, really proud of this. All right, let's go on to number 6. So Yes, this is the application mode. So now then, okay, so now y'all had a bit of practice on constructing those rectangles. Now, how would you approximate the area under that function? And the function was 2 to the x. I couldn't really do power here on Desmos, so I put 2 to the x and discuss how you would connect it to the big ideas. So one group says that they would preferably use the left endpoint. They'd find the area of the rectangles, then they find the area of the triangles and add it together. So I think what they mean by the triangles is like if they're using the left endpoint, like this one here, they're talking about these white spaced triangles that are under the graph is what they mean. Awesome strategy. In order to approximate the area of the curve, we first have to calculate the height, yes, and then we add the height of each rectangle. Okay. You find the height, then divide by the width. My only feedback would be instead of dividing, we want to multiply because remember base times height. So that's just my only feedback for that one. Again, a lot of your the preference is left Riemann because you know your left Riemann for this particular example is giving you the underestimate. So a lot of people are preferring to use the left. Totally cool. Just make sure that in your mini final you just divide. Like, why do you prefer to use the left? And y'all can take a look here. Ooh, there's a sigma notation connection. I like that because that's connecting to the big idea for Kelly's group. Awesome. And then let's see what else. All right, very descriptive about how to add up all the areas in Williams' group. All right, y'all can take a look at those ideas right there. Super great. I love this. Our group use people. Who are those people? Who is William? You're so funny. So Miles, I anonymized everyone's name so nobody feels called out. So again, it's because I clicked on anonymize. But anyways, let me go ahead and bring us back into the wrap up now, everybody. This was awesome. Everyone who participated will be getting credit. I also I don't know, I forgot who a group it was. There was like a group who like I went in there and the first time they were discussing, they had like an incorrect graph, but I was like quiet. I just wanted to see how they're gonna work it out. I stepped out, came back in, and they were like discussing, and they were like, okay, let's start over, and they redid the work. And then the second time I came around, it was accurate, and all of that was not through me. That was because you all were discussing it together, and that was like the most amazing stuff. That's exactly what we're talking about, learning through collaboration and discussion. So just shout out to that group in particular, in general. All right, y'all, let's go ahead and jump into our checkout question. Yay. And by the way, yeah, we're going to be ending probably a few minutes earlier. Maybe that will give you time to take a look at the mini final and or finish up the Sunday's assignment if you didn't get to. But here's our checkout question though. Which part in the process of constructing the Riemann rectangles today in your groups was the most challenging? Or you could talk about what was the easiest. And here's the steps again as a reminder, like what was the most challenging or what was the most easiest? Or if you don't want to talk about any of that, you could say what questions you have about this general process. Go ahead and use the chat, and then that's going to be our checkout. All right, y'all. I'm interested to see what y'all think was the most challenging, easiest, or any questions y'all have. Yeah, I think the most challenging part is to draw them because I can't do straight lines. Yes. And I don't know if it's just me, like even when I'm in the classroom and even if I use a ruler, I still get like slanted lines. I don't know what's up with that, but okay. The easiest part was finding the width. Yes, drawing the rectangles, LOL. Yay. My easiest was constructing. The easiest was deciding on which endpoint I'll use. Is to draw the rectangles because then you have all the information. Awesome. Step 2 was the most challenging because we weren't sure where to start. Yes, I think that was the group that I propped. That one was my favorite. It was easy to make the boxes because it was just drawing. Step 4. Wow, that's great. Step 4. I was worried that step 4 would be confusing when I'm like, use this endpoint. Like, you know, it's very technical language, but I'm like really happy that y'all are like, you know, grappling with it. Awesome. And then feel free to send me privately if, you know, you don't feel comfortable sharing what you thought was easiest or most challenging. You can send it to me privately. Totally okay. All right, y'all. And then thank you for listening to my suggestion for groups. I think step 2 was kind of challenging. Yeah, partition the x-axis. It sounds scary, that word. And like actually dividing up. Yeah, that's the part where I actually saw groups kind of like really talking about it. All right, y'all. Thank you so much for your participation. This was a great class. Again, make sure y'all take a look at the mini final because our next class, we're going to do some work with it. And also take a look at the big ideas packet. And then, yeah, step 2 was totally challenging. All right, y'all. Have a great day. I'll see you all, I think, tomorrow. Bye, everybody.
Bye.
Bye, y'all. It was such great work today. The groups were awesome today. Bye, y'all. Enjoy your lunch. Bye.